Today we're going to talk about growth and decay exponential functions. So if you see this graph for the growth, if you're starting from the left, notice that you're going to be increasing. Some key words for growth would be increases, doubles, triples, and of course growing. For decay, when we start from the left side, we're going to be going down, we're decreasing. So keywords would be decrease and half-life. See if you can identify if this is a growth or decay. A strain of bacteria growing on your desktop doubles every 5 minutes. Assuming that you start with only one bacteria, how many bacteria could be present at the end of 96 minutes? So the keywords that you should have underlined is double, and growing. So this is a growth. On the other example, let's go ahead and read that. Radioisotopes of different elements have different half-lives. Magnesium-27 has a half-life of 9.45 minutes. What is the exponential constant for magnesium-27? Round to 5 decimal places. So if you underline the word half-lives, then that would be one of your key terms. That one indicates that it's going to be a decay exponential function. Okay, let's move on. So now we're going to be plugging in numbers into these exponential functions. So on your homework packet, on the first page, you have a homework titled Exponential Functions. This is example 1. So we have f of x equals negative 2 to 2x plus 1 power. And we're going to find f of negative 1. So if we have f of negative 1, that just means that wherever we see an x in the function, we're going to now substitute and replace it with a negative 1 instead. So we have f of negative 1 equals negative 2 to 2 times negative 1 plus 1 power. So we'll go ahead and distribute the 2 and then combine like terms to get negative 2 to negative 2 plus 1 power. And that's the same thing as negative 2 to the negative 1 power. If you remember your exponential rules, we know that when we have a negative exponent, we just flip the fraction and the negative turns into a positive. Now, whenever we have just a number like 2 by itself, we can always put a 1 in the denominator. So now it becomes a fraction, so we can flip it. So that's the same thing as 1 over 2, negative 2 to the first power. And that's simply just negative 1/2. And that equals f of negative 1. Now let's move on to number 6 on our homework first page, the exponential functions. So we're going to solve by log being both sides. So on example 6, I rewrote the problem, and notice I put a big gap between the equal sign and the 3. So we have 3 to the power of negative 2v equals 3 to the power of negative v. From here, to get rid of the 3, we're going to log b both sides. Now what is b? B stands for the base. And in this problem, 3 is our base, so we're going to log 3 on both sides. So this is why I left such a big gap right here, is to fit the log 3 in there. So that makes the 3's cancel out. So the 3's and the logs cancel out. And so you're just left with negative 2v equals negative v. From there you can add 1v to both sides. 1v minus 1v is 0 v's. Negative 2v plus 1v is negative 1v. Divide by negative 1 on both sides of the equal sign to get rid of your negative. So there you're just left with v equals 0. Okay, let's do example 8. So we have 2 to 2n minus 3 equals 64. But notice we do not have the same base. We have 2 on one side and 64 on the other side of the equal sign. Well, we could write 64 as 2 to the 6th power. So now we have the same base on both sides. To get rid of that, we're going to log b both sides again. And what is b? It's 2. So you're going to log 2 both sides. That gets rid of the 2's and the logs. So now you're just left with 2n minus 3 equals 6. So from there, add 3 to both sides of the equal sign. So you have 9 equals 2n. Divide both sides of the equal sign by 2 to get rid of this 2. 2 divided by 2 is 1. So now you're just left with n equals 9 halves. Okay, so now we're going to move on to the section that's called Solving Exponential and Logarithmic Day 1. So we're going to look at example 5. We have 10 to negative 6x plus 8 equals 68. Well, before we do any logs or exponents or anything like that, we first want to isolate that term. To do that, we have to subtract this 8. So we're going to subtract 8 on both sides of the equal sign. 8 minus 8 is 0, and 68 minus 8 is 60. Oh, but we still do not have the same base. So when that happens, we're going to get rid of one of the bases first. Let's get rid of this one, since this is the one with an x. So we're going to log 10 both sides. And they want you to approximate this one. So it will be a decimal answer. The log 10 and the 10 cancel. And so you have negative 6x equals log 10 of 60. And if you're using something other than a TI Inspire, if you just put log, it's automatically going to assume that it's a 10. So you're going to divide both sides by negative 6 to get rid of that. So if you put that in the calculator, put in log 60, close parentheses, divided by negative 6, you get approximately negative 0.296